We are on to the next process. I don't understand something. Just told me to remove the rear panel, but I never went through a step to put the panel on. And it's the one on the back here. This is electron. I don't understand. Oh man, we're going to be doing some open heart surgery here. So it wants it to be faced on the table, on its back, towards the user. And if it gets pretty technical here, I will move this around so that y'all can see. Take it back. I read it wrong. Oh, sit down. There we go. Now this I'll be able to share with you real easy. Sweet, I like this. They have standoffs. Should be 8 of these. And then, because we need 8 of other things, none of these add up to 8. So we're just going to put them back in the bag. Now, I think this is where the rest of our components are. We have 8 6mm and 8 8mm button head cap screws. 6, 6, 8, 6, 4, 8, 6, 8, 8, 6, 8, 8, 8, 8, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And we need those nylon washers that I have already used. I have to figure out where to find other M4 washers. I want to do the plate later. I don't know why this is done now. Well, I do, because we put this in. Ooh, I have an idea. I'll take one out. I'll put a different one in. Yeah. Now I won't even have to recalibrate it. Smack. That's a decent tolerance. We have solution. We have a DuX5 and a Duet 2. I got the Ethernet. You can also get Wi-Fi. I got Ethernet because we have Raspberry Pi setups for Octoprint already, and they're running on Ethernet as well. So just Ethernet works for me. Plus, this might end up in a space where Wi-Fi really isn't an option. I've never gotten an ESD bag that's been sealed. Never gotten anything in that. They've always just rounded it over, but these guys decided to actually heat crimp it and seal off the bag as well. I'm a little worried about that because I didn't include any sort of desiccant and they just tossed it in, which should be fine. But if moisture had gotten trapped in there, there'd been no way for it to breathe and get out. Not a huge worry. A little not super comfortable with that. Kind of poor instructions. I guess we'll just swing it with this. Best I can make out is a red strip is not on this side. Not that you can see it on that side, but the red is not on this side. The board in the picture looks like this with the connector there. So we'll go with that. They commonly suggest that you reference where the steppers are in relation to the board. Another thing I'll point out, because it's not, is absolutely nowhere in these instructions so far have been arrows. I might be a little on the young side, but I have spent a large number of hours as a co-op writing standardized work instructions. Arrows aren't just there to look pretty. They are miracle workers. Like, picture speaks 1,000 words, but if an arrow's in there, it speaks 2,000. Or I guess more concisely, it tells you which 50 of the 1,000 that it wants you to focus on. It really goes a long ways. I haven't done a logo set in a half while. I don't know if they include any sort of arrows or not in their picture diagrams, but I know words are minimal. That's me inclined into thinking that they included arrows because it's Legos. Like, what are you gonna say? The 2x4 block with half a slanted edge goes on top of the 2x8 block with a corner post that is inverted. I mean, yeah, you can go all technical if you want, but you're bound to lose someone, just like I managed to lose a screw somehow. I don't think I lost one, I just misplaced my buddy. I gotta make sure I get a 6mm and not a 8mm, because otherwise I'll be short-handed next time. There's also plenty of 4s left. It's like doing a Lego set that's already been done once. Alright, on the next one. Do I get more stickers? I bet I get more stickers. Oh, I got cables too. Hot dog. Connectors, yeah, there's the stickers, look at that. And yeet. Yeet. Yeah, so this is what I'm used to, where it's nice and open, moisture can come and go as it needs, and you just slide this out. So this chip right here is the difference between the Wi-Fi and the Ethernet, and all they did was they soldered this in for you and put nice little standoffs there. That's it. So if needed, a person really could very easily pull the solder off of these and throw a Wi-Fi chip on here, but that shouldn't be needed. So according to the image, they actually flex the cable down underneath both and then back up again. So I'm going to attempt to do that because that looks nice and satisfactory to any level of OCD and perfectionism. And with an already beautiful machine like this, like any criticism I give, like it's not given as in a negative attitude. It's suggestions to help them, to help you, to help me. I want to tighten the boards first because the standoffs are not secured to the acrylic yet, and that means that I can only tighten these boards so much, and that's a good thing in my opinion. And then whenever I go and I tighten the standoffs to the acrylic, I can tighten it, and it'll have that clamping force that I already put onto the boards to hold the standoffs in place, so I can actually tighten those fairly well without having it affect anything, and then I'll be reassured that my standoffs are not going to move on me if I ever need to take the duets off again for whatever reason. I really hope I don't have to. I hope it doesn't come to that. But like, sourcing parts like this is one of the big reasons about why I wanted to get this kit first before I went off and tried to do my own. Clearly it already exists. This is going to have 32-bit drivers and it'll just be beautiful. This is going to be really handy and really important for the tool changing side, because each of the tools is going to be mounted and is going to have a known operating style. So like, you have your 4 different filaments. They're all going to be set and technically on and plugged in when mounted in here, and that's very important instead of trying to do like a mux and switch between 4 different tools and only use one driver for a single tool at a time. They're all ready to go, so if you know what the next tool is, you can get it up to like a pre-temp. So you could have like a standby and then a on deck and then a running temperature settings. If you're really going to run this smoothly, where you can ramp it up 3 moves before it's going to finalize. And so while it's ramping up to the pre-temp, it's finishing off the print that the current hot end is using, and then it can actually ramp up to operating temp while it's placing the other tool, and then it can come and grab it at operating temp, extrude. It can extrude and have like a wiper on it while it's still in its holder. Like, that's my ideal state, is to have wipers at the holders, so they can just extrude out and it'll be happy there. It can just grab and go. Like, it's already extruded, it's already completely primed. That would be the ideal setup. I don't know if that's going to be a feasible case though or not. Looks like next is power supply. Curious how big this bad boy is. So that's an 800 watt hot plate. This is a pretty small power supply to be pushing 800 watts plus, like even if they only run one extruder at a time, plus the power to run one extruder. This will barely do 800 watts. I don't really like that. Like, I get it that it's probably not actually ever going to run that hot plate at 800 watts, but I would rather have my power supply be rated to operate all my components so that I have quicker startup times than being like, all right, I'm going to run my hot plate up until it's temp before I start up my nozzle temps. Because now I'm pretty sure, because that's the only time it's going to run at 800 watts is to heat it up. The rest of the time it really doesn't matter. I ordered a 110 setup. They left it on 220, sorry, 115 and 230 for those that care more. I'm curious to see if there's going to be any sort of like calibration to this thing too, as a part of the tuning, to get this up to make sure that as it's running, we're getting the correct voltages and amperage. Not that it matters a whole lot, I doubt we will, but I don't know what this is coming from factory. And if I know E3D didn't touch it because it was in the shrunk wrap, so I know that they didn't verify that this is outputting to whatever level is their standard. Well, that's almost like insulting. It's saying to put the Duet. There's also absolutely no name brand on this power supply. So what's truly powered by Duet 3D? Is it the printer or is it the power supply? I want to go with power supply because that's more funny. So I'm out of nylon except for the, and there's 4 screws in here, but I don't use these screws. Also, their bag labels mean like absolutely nothing. No correlation to anything with them. I don't think this is going to be long enough. It says I'm supposed to have some 12 millimeter long. Oh hey, I found another bag. Never mind. The struggle is real. Your 12 millimeter. Yeah, that looks better. Okay, do a quick check. Looks like they have 2 different power supply setups here. One will work and one will not. They also have extra holes with threads and nuts, embedded nuts that we don't use. So for this one, looks like we're using this 4 small holes and we're putting them in here. And according to scrolling through, that side is going to go to bottom and is now indicated by the sticker. Although I'm half tempted to put the power supply upside down just because logic. Alright, I'm just going to take this and rotate it. Because doing that face down is not working. There we go. Spanner for the win. Ooh, ooh, they really did it good this time. Okay, well they were long screws, but they barely made it through, but they're holding. Alright, well it physically doesn't fit that way. Seems to line up pretty well there. I hope we don't have to plug something in there. Should I move it down just in case? Should move it down just in case. Alright. It's closer to metal, closer to ground plane. We're set. Apparently the next step here is to start working on extruders. So I decided I'm going to do one of each. I'm going to do a full-on Hemera direct drive extruder setup, and then I will also do a Hemera Bowden tube setup. So we'll do 2 Hemera setup. And I'll go ahead and pull up the actual Hemera direct drive extruder setup after this one. So I'm going to do 2 setups though. One with the Hemera Bowden drive and one with the Hemera direct drive. And we'll do that so we can have a little bit of an idea of what the differences are and how to install both systems onto here. These are just warnings saying don't use the wrong screw length where the screw will bottom out. So like you can put a nut inside of here. You want to make sure that the screw only goes into the nut and never touches the casing on the backside, otherwise it will drive that nut into the casing and it will destroy the casing here. It'll just break it out. Makes sense, but be smart. For this, literally all it says is just go ahead and take this, clip it in, like apparently that's how they make these Bowden connector pieces. Slide it in, it wiggle wobbles, put this clip in just for safe keeping. You will remove this clip whenever you need to put the actual Bowden tube in, but for now, we're going to keep it in there for install and safekeeping so we don't lose that clip. And then what this is going to do is going to just drive all the way down inside. We're just going to do a snug fit, take something, pliers, whatever. That is a hard steel. Don't worry about scratching it. So all it's saying is right here, you have this white piece. I'll push it out for you. That's too far, and you can also retract it. And it's too small. What we're aiming for is for it to be just flush with that piece. And apparently that's the correct amount of tension for the Hemera drive. Nice, simple, straightforward. Probably all they're doing is kind of like a drywall screw, driving the screw down into here and causing it to separate and increase the distance between this wall and this wall, which drives that spring away, which we could probably calibrate that / increase compression, but for now it's fine. But I do like this. It still has the release ability, although it's not very far, not much of a release. They did install 4 nuts here for us. Motion systems. We need to get motion systems, which is from our lovely set of everything here. I want to guess it's these guys. M4s. Okay. So it looks like there's supposed to be a black piece that sits across there and has right angle inserts that then can be sat flush up against the electronics plate. I am not seeing anything like that. Oh, I know what it is. We're getting into 3D printed pieces now. Step 1, download and print 2 Hemera Bowden brackets for each Bowden Hemera. Right on. Tell you what, let's just switch over to the actual Hemera, because we shouldn't need any fixturing for that. Watch us need it. We'll get that running, and then we'll make one of the first test prints after we get a couple of test prints in. We'll make one of the first actual prints to be the brackets in order to mount the Bowden, and then we can do that. And that might have to be another video. This one's already crazy long. But yeah, at least we have everything aside from that. At that point, they might as well just have made those aluminum. I want to just wrap that up. I want to thank you guys for joining me today, and I will get these parts printed probably on the Ender 3 and get those set up. I'll check the rest of the manual, see if there's any other parts I need throughout the rest of it. We'll look forward to a round 2 with assembling the tool changer. I really appreciate you guys coming and joining me today, and I wish you all the best. God bless and take care.